Hi everyone, good day. So we are from Group 2. We are gonna present on our project assignment which focuses on ANOVA and numerical analysis on optimization, which is Simplex. And here we have me, Afrina, and Shahmi, Kaviraj, and also Mustaqim. So as you can see here is the problem that we are working on. But first, I'm going to talk about how we solve this problem. So first, we identify the variable, objective constraint, objective function and the constraint. And then we put all the inputs that we get into Excel and finally use solver in Excel to solve. So the solver that we are using here is the LP Simplex. And then we're gonna do some discussion and graph that we extract from this problem. Here are the formulation, which is the variables. So X is for the smartphones, Y laptops, and Z for tablets. And the objective function is we use Z for profit equals to 2,500X plus 3,500Y and plus 1,200Z. And the constraints are 4X plus 3Y plus 4Z equals or less than 800, which is that is the information that we get from the labor hours, and the information we get from raw materials at 8x plus 5y plus 4z equals or less than 1000, and the information that we get from machine hours is 4x plus 2y plus 3z less than or equal to 600. And here we use a non-negativity to get positive answers.
This is the Excel sheets to use Simplex to solve this using Simplex. So at first row, we have the product, smartphone, laptops, tablet, and total use, and then also constraint on the F columns. So the profit for every objective is for smartphones is 2,500, laptops is 3,500, and tablets is 1,200. This decision variable will change according to the results. So for the labor use, so the labor use is every column times with the products and total sum. So the constraint is for labor use is less than 800. For the raw materials, the constraint is less than 1,000, and the machine time use constraint is less than 600. So the total profit is the decision variable times with the profit number and plus all together to get the total profit. So as you can see on the right side, this is the solver input. So for the variables, we input the maximum total profit. We set to max. Objective. This is the objective formula, which is set to maximize, and then the variable function, we set the decision variable, so this will change. And then this is the constraint that I put for every labor use, raw material use, and machine time. So I will show you the total we get the answer. So as we can see here, this is after the Excel calculate. So 200 laptops is the most profitable. So you can see laptops is 200 here. Labor use times all together, total profit 7,000. So labor use is 600, which is less than 800. Raw material is 1,000, which is to the max of the constraint, and machine time use is 400, which is less than 600. So I'm going back to the Excel. So for the discussion, as we can see here, for the blue color is the thing we use, and the red color is the available resources. So you can see the labor, as I said, labor is 600 and available is 800. Raw material we use fully, and machine time we use 400, and available is 600 hours. And I think we're gonna move to the problem number 2. And I'm gonna give to Kavin Raj.
So yeah, I'm going to explain about the methodology for problem number 2. Okay, so for the purpose of the analysis to determine the fertilizer type and growing condition significant effect, crop yield. Then we move on to check the interaction between two factors. And then we estimate the random error, which is the question needs. And we have the method we used is two-way ANOVA with replication. Okay, next. So it's a experimental design. The two factors that's involved in the question is fertilizer type, got 4 levels, and growing condition of 2. Then we have total of 24 observation. And the response we get is crop yield. And factorial design is 2/4 layout. So what is two-way ANOVA? So this is the method we're going to use to solve this problem number 2. And the software we're going to use is MATLAB. And what's specifically good about MATLAB is the ANOVA is already built in the software, which is known as a MATLAB function, which can perform one-way or two-way ANOVA problems when we build and run the code. And we not only did MATLAB, but we also had an additional method to find a solution for this question. So they got actually for the method using for this question is tabular method, but there's actually another method called matrix. So in this case, we're only using MATLAB for simulation and tabular method for handwriting experiment. Okay. So in MATLAB is involved 4 paragraphs of coding, which we obtained from Google and YouTube tutorials. And then after we did our MATLAB, it's still a necessity there to show that our calculation is correct because it's just a simulation. So for report purposes, we did our hand calculation, manual calculation, as is shown in the slide here.
Hello. So now I will elaborate on the results obtained from problem 2. So here is the table specifically for fertilizer. As you can see, we have 4 kinds of fertilizers with the replicate data. And moving on to the next slide, we can also see that the total from each fertilizer has been summed to the right column, and also it has been the squares has been summarized. Yeah, have been added up to the bottom and also divided by the observation, which is in this case divided by 6. First, the thing about ANOVA, two-way ANOVA, is we can see we can analyze a problem for 2 independent variables with 1 dependent variable. So in this case, this is the first independent variable. Moving on to the next slide, we can also see, and this is for the growing condition, which is the greenhouse and field. So that's 2. So we can, the summation for each case, which is the greenhouse and the field, can be seen on the rightmost column. And each of the summation is squared. And also we divided with the observations to get the second sum of square treatment, which is in this case is growing condition. So there are these are the 2 independent variables that are present in the problem number 2. And for the next slide, we are calculating this is the table for fertilizer and growing condition together and their interaction. We can also see that after summing all the data on the right column as well, you can see the summation square at the bottom with the observation. And then finally, we can tabulate the data. Conclusively, we can conclude that the interaction between environment and fertilizer all can be rejected, which means there are these factors contribute significantly to the mean crop yield. So we can see that the mean crop yield by fertilizer type and growing conditions in a histogram by MATLAB output has been done by my colleague here, which is, as you can see, significant for all those three factors. Yeah. Problem 2. Thank you very much.
So with that, we are done with our presentation for the project assignment regarding ANOVA and Simplex problem. Thank you.